students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel Ines Online Math Classes. Today we start with a new chapter, the Binomial Theorem, and our today's topic is the factorial notation. Okay, so the factorial notation. This is the sign for the factorial. This exclamation mark, and for n greater than equal to 1. N is a positive integer. N factorial is n times n minus 1 times n minus 2. That means it just goes on decreasing in steps of 1. That means if I take 5 factorial, it will be equal to, we start with 5. In factorial, we start with n. So 5 factorial, we start with 5. Then 5 minus 1, that is 4. Then 5 minus 2, that is 3. 5 minus 3 equal to 2. And finally, the last number will be equal to 1. Okay. So 5 factorial equal to 5 times 4 times 3 times 2 times 1. Of course, we will be multiplying these numbers. So 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. 120 times 1 is of course 120. So 5 factorial is equal to 120. Okay. So this is how you get the value of a factorial, and if you have to write it in this expression form, then 5 factorial equal to 5 times 5 minus 1 times 5 minus 2 times 5 minus 3. It goes on till you reach the number 1. Okay. And this is read as n factorial that I have said. And 0 factorial, this you have to remember. 0 factorial, you obviously don't have 0 times 0 minus 1. You cannot go to the negative side. 0 factorial is equal to 1. Okay. And these factorials are widely used in the permutation combination questions and also in the binomial theorem expansion questions. Okay. And we are doing the binomial theorem chapter, so we will be seeing the usage of this factorials. Okay. So now for this session, let us do few questions related to factorials. So the first question says express in factorial form. There are 3 subparts, so let us start with our answer. Subpart A. Now we are seeing it is starting with 7, then 7 minus 1, 7 minus 2, 7 minus 3 is 4, 7 minus 4 is 3, 7 minus 5 is 2, and 7 minus 6. We come to 1. This is the last number. First number is 7 and the last number is 1, and it is going on decreasing in steps of 1. So, it is 7 factorial. Okay. Next one, subpart B. Let me write the question. 5 times 4. But this is not going up to 1. It is just 5 times 4, and we have to give this in a factorial form. So I have to come to 1. The starting number is 5. Then 5 minus 1. Then it will be 5 minus 2, which is 3. 5 minus 3, which will be 2. And 5 minus 4, this is 1. We stop over here. So, we have included this part. This part was not there in the question. But since the question is asking us to express this 5 times 4 in factorial form, I had to introduce this part. But I cannot introduce this part because the 5 times 4 is equal to 20 and this 5 times 4 times 3 times 2 times 1, we have seen this to be equal to 5 factorial, and the value of the 5 factorial is equal to 120. Definitely 20 is not equal to 120. So, just by addition of this part, I am just changing the value of the expression given. I cannot do that. Therefore, since I have added this in the numerator, I will be adding the same thing in the denominator. 5 times 4 can be thought of as 5 times 4 over 1. Let me write over here. 5 times 4 is equal to 5 times 4 over 1. Okay. So, the denominator is there, which is equal to 1, and we do not write the denominator of 1 explicitly. Every integer can be expressed as a rational number with a denominator 1. We do not write the denominator of 1 explicitly, but it is there. Okay. So, since we have added this portion in the numerator, we have to add this portion, the same thing, in the denominator. Otherwise, the value will be getting changed, which we cannot do. So, we add this same part in the denominator. Now, this whole thing is 5 times 4 times 3 times 2 times 1, which is equal to 5 factorial. Okay. Now, I am in a position to express the numerator in a factorial form. But what about the denominator? In the denominator, I am seeing I can just ignore this 1. It is not required. So, I start with this number 3. 3 and then 3 minus 1 is 2, and then 3 minus 2 is 1, and we stop at this 1. As soon as we get this number 1, we stop. So, the starting number is 3. Therefore, this will be 3 factorial. Okay. Because for n factorial, we have seen the starting number is n. n times n minus 1 times n minus 2, it continues till 1. So, this is 3 factorial. So, the subpart B's answer is 5 factorial over 3 factorial. Okay. Coming to the subpart C. 9 times 8 times 7, and the denominator is 3 times 2 times 1. Okay. 3 times 2 times 1 is 3 factorial. We have seen this. But what about the numerator? It is not in a factorial form, but I have to get this in a factorial form. So, what do? I have to go on adding numbers in steps of 1, decreasing numbers, and I'll be stopping at 1. So, after 7, it will be 6, then 5, then 4, 3, 2, and finally 1. So, I have added this part in the numerator. So, I have to do the same thing in the denominator. 6 times 4, 5 times 4 times 3 times 2 times 1. Okay. So, the numerator is equal to, it is starting with 9 and ending at 1. Therefore, this is 9 factorial. What about the denominator? The denominator, we are seeing that this part is 3 factorial. So, we write 3 factorial. Multiplied by, because there is the multiplication sign, so it is multiplied by. And what is this part equal to? This part is equal to, over here, it is starting with 6 and ending with 1. So, It is 6 factorial. So this is 6 factorial. Okay. So this is the 7 factorial is the answer for the subpart A. 5 factorial over 3 factorial is the answer for the subpart B, and for the subpart C it is 9 factorial over 3 factorial times 6 factorial. Okay. Let us move on to the next question. Okay, so the next question says simplify without using a calculator. Fine. Let me just, I don't have much space, so I have to do this. I am starting my answer over here. Okay. So this is the subpart A. 12 factorial over 11 factorial. Now, always we have to try to bring the, over here we are having 2 factorials. We will be trying to bring the higher number, the greater number factorial. We will be trying to express rather the greater numbers factorial in terms of the smaller numbers factorial. Because 12 is more than 11, our target will be to express 12 factorial in terms of 11 factorial. Okay. So what is 12 factorial? It will be 12 times 11 times 10 times 9 times 8 times 7, and it will be just going on, continuing till 1. Okay. And what is 11 factorial? It is this part. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This whole thing is 11 factorial. Okay. So that is why I was saying that our target should be to express the greater numbers factorial in terms of the smaller numbers factorial. So we can cancel these two. And the answer will be equal to just 12. So 12 is the answer for the subpart A. Okay. So the subpart, I did not do these boxes, draw these boxes for the first question. So for the subpart B, 8 factorial over 6 factorial. 8 is more than 6, so our target should be to express 8 factorial in terms of 6 factorial. What is 8 factorial? It is 8 times 7 times 6 times ... or let me write 5, 4, I have space so I may continue, 3 times 2 times 1, and 6 factorial is times 3 times 2 times 1. So this part is 6 factorial. This is of course 6 factorial. So these two will be getting cancelled and we will be having 8 times 7, that is 56 as the answer for our subpart B. What about subpart C? 10 factorial, that is the largest of all the three numbers that I am seeing, 10, 8 and 2. So, in this case, what should I be doing? I'll be expressing 10 factorial in terms of what? 2 factorial or 8 factorial? I'll be taking the bigger number. I'll be expressing this 10 factorial in terms of 8 factorial. When we are having two numbers factorials to be, and we have to choose from these two, we will be going for the bigger number. Obviously, because 10 factorial will be 10 times 9 times 8 times, it will be coming to 2, but why should I be continuing up to 2 when I am getting 8 much earlier? So I can write this 10 factorial as 10 times 9, and now I won't be writing 8 and all those, I won't be going up to 1, I would be directly writing this as 10 times 9 times 8 factorial, because I think that you have now understood how are the numbers decreasing. Okay, so 10 times 9 times 8 factorial is equal to 10 factorial, and this is 8 factorial times, this is multiplication obviously, times 2 factorial. So these two will be getting cancelled and we will be having 10 times 9, 2 factorial is 2 times 1, which is 2. So this is 5 and 5 times 9 is 45. So the answer for our subpart C is equal to 45. Coming to subpart D. 4 factorial times 5 factorial over 3 factorial times 6 factorial. Now we are seeing we are having 2 factorials in the numerator and 2 factorials in the denominator. Okay, so and you may express the larger number in terms of the smaller number. That is the method. Which two numbers we will be selecting, that is totally up to you. You can take 4 and 3, 6 and 5, or 5 and 6, or you can take 4 and 6 and 5 and 3. You can pair the numbers in any way. One from the numerator and the other from the denominator, so that you can cancel them. Okay, so I am selecting 4 and 3 and 6 and 5. Okay, you can take 4 and 6 and 5 and 3 as well. But since I am taking 4 and 3, I write 4 factorial as 4 times 3 factorial times, out of 6 and 5, 5 is the smaller number, so I keep 5 factorial as it is. And 3 factorial, 3 is the smaller number, so it stays. And 6 factorial will be written as 6 times 5 factorial. Okay, so these two will be getting cancelled and these two will be getting cancelled. So this is equal to 4 over 6, which is equal to 2 over 3. Okay, and in case you are doubtful whether you will be getting the same answer if we pair the 4 and 6 and 5 and 3, let me show the same working with those pairs. Okay, so I can take 4 factorial, I am writing the question once more, 4 factorial over times 5 factorial over 3 factorial times 6 factorial. This is equal to, I am taking 4 and 6. So 4 is the smaller number, I keep it as it is. Between 5 and 3, 5 is the bigger number, so I have to express 5 factorial in terms of 3 factorial. So it is 5 times 4 times 3 factorial over 3 factorial, and between 4 and 6, 6 is the larger number, so I have to express 6 factorial in terms of 4 factorial. So it is 6 times 5 times 4 factorial. These two will be getting cancelled, these two will be getting cancelled, this will be getting cancelled, and we have the same fraction 4 over 6, which is equal to 2 over 3. Okay. So we come to the next question. Simplify. Again, you have two subparts Actually, I had tried to take all the factorial questions in one session, but the session is getting longer, so we will be having one more session on factorial notation questions, but this question will be the last question of this session. Okay, so subpart A. n-1 factorial over n factorial. Now, these are variables, but obviously n is the larger number between n and n-1, whatever may be the value of n. N is a positive integer, otherwise we cannot have these factorials. N is a positive number, positive integer, or positive number, and n-1 is a number, a positive number where 1 is getting subtracted from n. So which one is the larger number between n and n-1? Obviously n is the larger number, and we have seen always we try to express the larger number in terms of factorial, in terms of the smaller numbers factorial. So we will be doing exactly the same over here. The method will not be changing because we are having some variables instead of some numbers. So it will be n times n-1 factorial. And these two will be getting cancelled, and the answer will be 1 over n. This will be the answer for the subpart A. What is the subpart B? N plus 1 factorial over n-1 factorial. So this is obviously, n is a positive integer. To that n, you are adding a plus 1 for the numerator, and you are subtracting 1 from n for the denominator. So which one will be the larger number, greater number? Obviously n plus 1 will be more than n-1. So our target will be to express this n plus 1 factorial in terms of n-1 factorial. Okay, so n plus 1, since it is n plus 1 factorial, the first factor will obviously be equal to n plus 1, and then the numbers will just go on decreasing in steps of 1. So n plus 1, we start with n plus 1, then it will be n plus 1 minus 1, that is n. Or let me write n plus 1 minus 1. Then it is n plus 1 minus 2 and dot 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 1 over n minus 1 factorial. And what is this part equal to? Now if I write this, n plus 1 stays as n plus 1. These two will be getting cancelled, and we have n. And what is this? N plus 1 minus 2 is n minus 1. If I take the next term, it will be n plus 1 minus 3, which will be equal to n minus 2. And this will be continuing up to 1. And what is this part? This part is nothing but n minus 1 factorial. So this part and this part will be getting cancelled, and we have the answer for the subpart B as n times n plus 1 or n plus 1 times n, or you can write as the answer as n squared plus n. Whatever you want, you can give the answer in either this form or this form. This is the factorial, there is this dot, or n plus 1 times n. It is totally up to you. All these are the same. So this is the answer for the subpart B. Okay. So students, let us stop over here for today, and we will be having one more session which will be containing more challenging questions on this factorial notation. We will be solving equations containing factorials. Okay. Thank you for watching this video till the end. We meet again very soon. So till then, bye.